Right now, we're gonna learn about differentiation. Let's go to the team members.
Hi, my name is Muhammad Ali Iskandar. My ID number is 202587 and 264.
Assalamualaikum, my name is Afif Khadijah binti Hairul and my ID is 2024689684.
Assalamualaikum, my name is Irfan Azali bin Khairi Azali and my metric number is 202-441-0866.
Hi, so now I'm going to explain question 1, which is explain the meaning of differentiation and what are the techniques of differentiation. Differentiation measures how a function changes as its input changes. If y depends on x, then the derivative dy dx tells us the rate of change of y with respect to x. We can think of it as the slope of a graph at each point. We use derivatives in many problems, such as to find speed, growth maxima and minima, and also how one quantity reacts when another one changes. Next, we are going to talk about the techniques of differentiation. First is constant rule. Constant rule is when we are finding the derivative of a constant. The answer will always be 0. The next is the power rule. The power rule states that power must times and then the power divides, subtract by 1. So as an example here, x to the power of n, and then n multiplied with x, n to the power of n minus 1. Next, product rule. Product rule is when two functions that are multiplied with each other. And then quotient rule. Quotient rule is when we use when two functions are divided by each other. And then there are also chain rule. Chain rule is when two or more functions are inside each other. As example here, gx is inside fx.
I will be answering question 2. Find dy over dx for the following functions. A, y equals to 9e power x 10x minus 3, and b, y equals to x squared plus 1 over sin x. For a, y equals to 9e power x times 10x minus 3, let u equals to 9e power x and v equals to 10x minus 3. For derivative of u prime equals to 9e power x, and for derivative of v, we need to use chain rule. So firstly, 10x minus 3 equals to sec square x minus 3. Secondly, x minus 3 equals to 1. So v prime equals to sec square x minus 3 times 1. Now we will apply the product rule. So the formula is dy over dx equals to u prime and v plus u and v prime. So now it will be dy over dx equals to 9e power x times 10x minus 3 plus 9e power x times sec squared x minus 3 times 1. Then we will factor out 9e power of x because there are two of it. So the final answer will be dy over dx equals to 9e power of x times 10x minus 3 plus sec squared x minus 3. Now question B, y equals to x squared plus 1 over sin x. Let u equals to x squared plus 1 and v equals to sin x. Now we will get that u is u prime equals to 2x and v is v prime equals to cos x. And then we need to use the quotient rule. Dy over dx equals to u prime and v minus u and v prime over v squared. So now we will get dy over dx equals to 2x and sin x minus x squared plus 1 and cos x over sin x squared. So the final answer will be dy over dx 2x sin x minus x squared plus 1 cos x over sin squared x.
Hi, so next I am going to explain question 3, which is find dy dx using implicit differentiation. Given ln y plus sine square x square plus ey equals to 5xy. So first we differentiate each term. So the derivative of ln y is 1 over y times dy dx. Why must we multiply it by dy dx? Because we are differentiating y. So the next one is sine square x square plus e to the power of y. So we differentiate the outer part, we get 2 sine x square plus ey, and then we differentiate the second part, which is sine x square plus e to the power of y. The derivative of sine is cos, so we get cos x square plus e to the power of y, and then we multiply it by the derivative of x square plus e to the power of y, the inner part. So the derivative of x square is 2x, and then e to the power of y is e to the power of y times dy dx. 2 sine x cos x is also equals to sine 2x. So we get sine 2x squared plus e to the power of y times 2x plus e to the power of y times dy dx. And then we differentiate 5xy. This we will be using product rule. So 5x is our u, x is our u, y is our v. So we multiply using the formula of product rule, we get 5y plus 5x times dy dx. After that, we will compile all terms, so we get this equation right here. After that, what we must do is to arrange and factorize dy dx. So after we rearrange the terms that contains dy dx to one side, like the above equation right here, we must factorize it like the below equation right here. So after that, after we bring the factorized part to the other side, we get dy dx to be on itself. Thus, we get the final answer. Thank you.
Right now, I'll be answering question 4. Question 4. Use linear approximation to estimate the value of 8.02 to the power of 2 minus 3 root 8.02 correct to 2 decimal places. The information that we could get from the question just now is fx equals to x to the power of 2 minus 3 root x, x1 equals to 8.02, x0 equals to 8. The reason why we got 8 for x0 is that we run out the x1 taking the closest value to it. In order to get the final value, first we need to determine the dx. dx equals to x1 minus x0. Replace the x1 minus x0 to 8.02 minus 8, and then you get 0.02. After that, you need to determine the f prime x equals to x squared minus x1 over 3. It becomes 2x minus 1 over 3x to the power of negative 2, 3. And then it becomes 2x minus 1 over 3 multiplied by 1 over 3 root x squared. And then it becomes 2x minus 1 over 3 root x2. After that, replace x with 8. So it becomes 2 multiplied by 8 minus 1 over 3 root 8 squared equals to 191 over 12. Next, we need to determine the fx. So from the information, fx is x to the power of 2 minus 3 root x. Now replace the x with 8 and we'll get 62. Finally, after gaining the x, f prime, and f, you can use the formula Lx equals to fa plus f prime a multiplied by x minus a, and then you'll get 62.32. In conclusion, differentiation is useful for computer science and actuarial science. For computer science, the concept of differentiation are embedded in modern computer techniques. Optimization algorithms, differentiation is the core of algorithms like gradient and descent, which are used in machine learning to train models. Meanwhile, for actuarial science, differentiation is very important for actuaries because it helps them to understand and predict how things change. For example, actuaries can set insurance prices accurately. This helps the company to make decisions using math. That's all from us. Thank you for watching.